Refrac in horizontal well. The rapid production decline in shale wells has prompted a new movement towards refracturing depleted or low producers. Over time, most horizontal wells will produce at a fraction of their initial rates, and large volumes of oil and gas will remain trapped within the rock, which may now be extracted through refracturing. The cost is between a quarter and a half of what it costs to drill and complete a new well. This video shows how to model a multi-stage fractured horizontal well which has been refracted. The options illustrated in this video are available under Numerical Analysis in Sapphire, Topaz, and Ruby. In this video, we show only the workflow in Ruby. In the current document, the reservoir, PVT and properties, and a multi-fractured horizontal well geometry are already defined. Under the Map tab, double-clicking on the well shows the well properties. Microseismic data have already been loaded for the well. The loaded data can be viewed using the microseismic icon. The microseismic option is specific to the UR add-on license. The microseismic data clearly shows that most of the frac job went to the toe of the horizontal well and missed the area closer to the heel. So in this case, the complex frac geometry has been adjusted to honor the microseismic data, and a few more fracs have been added closer to the heel, which will be contributing after the refrac, after 3 years. To modify the perforation, the Edit Perforation option is selected, and the existing perforation length is adjusted to cover the new fracs closer to the heel of the well, which will contribute after 3 years. To create a second perforation, the new perforation option is enabled, and the perforation is placed closer to the toe of the well. Its length is adjusted to cover the existing fracs. Next, under the Time-Dependent option, the Perforation Closing Intervals tab is selected. For each perforation, the time of opening and closing is defined. This can be done repeatedly. The time may be specified as elapsed or absolute. For this case, perforation 2 and the original fracs open at all times are kept. As there is obviously no refrac job in the first instance, perforation 1 remains closed at the outset. Back to the Run tab, a simulation is run to forecast the model based on a constant bottom hole pressure for 20 years. Once the simulation is complete, maximize the 3D plot to play back the pressure fields. Once done, a new run is created and called Refrac. This is a copy of the first run, except this time perforation 1 will contribute after 3 years. Following the same process previously done for the first run, go to the Map tab. Under Well Properties, select Time Dependent. Under Perforation Closing Intervals tab, a perforation opening event for perforation 1 is added, and a time of 3 years is set. Validate by clicking on OK. Under the Run tab, The simulation is run again. Once the simulation is complete, in the maximized 3D plot, the pressure fields are playback, one step at a time. After 3 years, the other fracs also start to contribute. The 3D plot is restored, and the well results plot is maximized to display only the cumulative gas production. Back to the previous run, the same process is repeated on the well results plot. Now, as the well results plot in the two analyses display the same channel, the compare option will show the EURs of these two cases. After 3 years, the EUR starts to increase post-refrac. The EUR values can also be compared in the results grid. The last Run tab shows the option to replicate the scenario and to add additional fracs in between the existing original fracs, and assign the perforation closing and opening times accordingly. Back to the Run tab. A simulation is run to forecast the model based on a constant bottom hole pressure for 20 years. Once the simulation is complete, maximize the 3D plot to play back the pressure fields. This concludes this video on the Refrac option in KAPPA-Workstation.